Welcome! For our next challenge, we depart from Christmas Island and set sail for the island of misfit toys. As we navigate its coasts, we stumble upon the square wheel yard and we dock there. As we explore the yard, we run into Garland Candlestick. Garland has forgotten the combination of their luggage and needs help to open it. Garland mentions Chris LG gave a talk about techniques we can use to guess the code of a luggage very similar to this one. After clicking the terminal next to Garland, we are presented with the interface for this challenge. The settings offer different levels of wheels to unlock. To clear this challenge, we need to solve the one with 4 dials, so we select that one. After watching Chris's talk, we are very familiar with this interface. We have 4 dials that rotate, allowing us to select a number between 0 and 9. We also have a key button that is pushed to open the luggage. If the number combination of the 4 dials is correct, the luggage will open. As Chris explained, when the correct amount of pressure is placed on the key button and a dial is turned, the dial will stick at the location of the correct digit for that dial. When a button sticks, we see a message indicating dial resistance and also get a sound cue. After testing a few times, we notice more than a single number sticks on every single dial, but it is also clear that some numbers stick a little more than others. We test our hypothesis by starting a new game. Let us press the button just close enough to the open position. As we start rotating, number 0 shows high resistance for the first 3 dials as it sticks more than once. In our last dial, number 6 shows more resistance than any other. We give the key button one last push and successfully open Garland's luggage. Let us explore an alternate solution by reviewing the challenge's source code. We start by right-clicking inside the challenge and selecting Inspect from the menu. We select the Sources tab in Chrome and start reviewing the JavaScript code. We eventually stumble upon a function named checkFriction. Per the comments inside the function, we conclude its purpose is to determine at what point a dial should stick. By analyzing the function in detail, we notice the presence of a few interesting variables, including friction coefficient, pressure, and probabilities. We take special interest on the line setting the coefficient of friction. The coefficient is set by extracting a value from inside the probabilities array, then multiplying it by the current pressure value, and then dividing it by 4. This last part is especially interesting as the player has control of the pressure value. If we set the pressure to 4, the multiplication and division portion of the calculation for the coefficient of friction gets effectively canceled. That is, as both values are set to 4, the multiplication and division operations cancel each other out. As a result, the probabilities will in effect contain a list of 10 values for each dial. The number with the higher probability value will cause the dial to stick and yield the correct digit for that dial. Now we start a new game and open the web console to test our hypothesis. First, we set the context of the console to the iframe of the challenge. We check the current value of our pressure variable. As it is set to 0, we press the button 4 times. We then confirm the pressure value is now set to 4. Next, we print the probabilities variable. We expand the array and see one item for each of our dials numbered from 0 to 3. By expanding the values for our first dial, we see the higher probability value corresponds to number 3, so we set our first dial to 3. For our second dial, the value is with the higher probability is also 3 and set that to 3. We continue for every dial and reveal the code of Garland's luggage. Hope you enjoyed this alternate solution. See you on the next challenge.